In our paper, we studied rational one-forms for correspondence of curves x and y, where x and y are projective smooth curves, and sigma 1 and sigma 2 are morphisms between them. We define a rational one-form omega of weight nu to be semi-invariant if sigma 1 upper star omega is equal to sigma 2 upper star omega. We also define this quantity called the conductor of omega, which is denoted as script c sub y comma omega, as the cardinality of the support of the divisor of omega. Our first result is if the degree of sigma 1 is not equal to degree of sigma 2, then this quantity, the conductor, can be uniformly bounded by an expression completely given in terms of the genus of x and genus of y and the degrees of the morphism sigma 1 and sigma 2. Here we would like to mention that in the case where the degrees are equal, where the degrees of the morphisms are equal, then there is no hope to actually bound this conductor. There are examples that come from Hegel correspondences where one can see that there are rational one-forms for which the conductor goes to infinity as the residue characteristic goes to infinity. Our second result is in the case where x equals to y equals to the p1 and the degree of sigma 1 is bigger than or equal to 14 times degree of sigma 2. In that case, if omega is semi-invariant, then omega has to be a new power of dt over t minus a, or it is a new power of dt squared mod t minus a times t minus b. Our third result is, now our correspondence xy sigma 1 sigma 2 is defined over a number field f, such that for all places p satisfying that the characteristic of the residue field at p is strictly bigger than 2 times degree of sigma 1 times degree of sigma 2, and for all these places p, it admits a semi-invariant form omega p of weight 1, which precisely means that omega p is of the form dt over t minus a to the power nu. Then there exists an endomorphism sigma of p1 defined over f such that our original morphism sigma 1 is in fact conjugate to a scalar multiplication lambda times sigma composed to the power h, and sigma 2 is conjugate to lambda times sigma composed to the power l. So this gives us a summary of our paper.